welcome to the next part of heat transfer utilities. Previously, in the previous lecture, we have discussed about different type of heat exchangers, their functioning, their anatomy, what are the integral part of different heat exchangers, what is the concept of heat exchange. In this particular aspect, especially we gave the major emphasis to shell and tube heat exchanger, then double pipe heat exchanger. Now, in this particular lecture, we are going to cover the plate and frame heat exchangers, corrugation within the heat exchanger. This is again very important phenomena. Now, let's have a look about the plate type heat exchanger. Now, plate type heat exchanger, it consists of a number of thin rectangular metal plates like this around the edges, and they are supported by the gasket and held together in a frame just like this. Now here you see that these are the plate heat exchanger plates. There are certain guide bars to remove or to adjoin all these plates. These are the gaskets. These are the tightening bolts so that you can make the compact structure. These are the support columns, and for here you see that this is the pipe connection, this is the fixed plate for the support, and this is the carrying beam, or sometimes referred as a carrying rail. Now the frame usually has a fixed end cover like here. So fixed end cover, or sometimes referred as a headpiece, fitted with the connecting ports, and a movable end cover, sometimes referred as a pressure plate like this here, follower or sometimes tailpiece, etc. In the frame, the plates are suspended from an upper carrying bar. This is the upper carrying bar to ensure proper alignment. For this purpose, each plate is notched at the center of its top and bottom edge. Here you can see these. This plate pack with fixed and movable cover. Now here you see that the fixed and movable covers is clamped together by long bolt. Now here you see that this is the long tightening bolt, thus compressing the gasket and forming a seal so that the fluid or whatever the liquid or any kind of heat transfer material, it should not get leaked. Now carrying bars, they are longer than the compressed stake, so that when the movable end cover is removed, the plate may be slid along the support bar for inspection and cleaning. See, inspection and cleaning is again very important to have a proper heat transfer. Otherwise, the dirt and dust or scales, they may become the part and parcel, and you know that these are not contributing any kind of heat transfer effect. Now each plate is made by stamping or embossing the corrugated or wavy, this is just like this wavy surface pattern on sheet metal. Now on one side of each plate, special grooves, they are provided along the periphery of the plate and around the port of gasket. Alternate plates, they are assembled in such a manner that the corrugation on successive plate contact or cross each other to provide the mechanical support to the plate pack through a large number of contact points, so that by this way you may enhance the surface area. So the resulting flow passage, they are narrow, highly interrupted and tortuous, and enhance the heat transfer rate and decrease the most, you can say, the important falling resistance by increasing the shear stress, producing secondary flow and increasing the level of turbulence. Now sealing between the fluid is usually accomplished by elastomeric molds gasket, and these are fitted in the peripheral grooves, which we have already shown in the figure. Now these gaskets, they are designed such that they compress about 25% of thickness in a bolted plate exchanger to provide a leak tight joint without distorting the thin plates. Now each plate has 4 corner ports in pair. They provide the access to the flow passage on the either side of the plate. It is just like this. Now, when these plates are assembled, the corner port line up to form distribution header for the two fluids. Inlet and outlet nozzles for the fluid provided in the end cover line up with the port in the plates, and they are connected to external piping carrying the fluids. Now, a fluid enters to a corner of one end of a compressed stack plates. So, these are the compressed stack plates. So, fluid enters from a corner of one end of the compressed stack plate through the inlet nozzle. Now, it passes through the alternate channel in maybe in series of parallel passages. In one of the channel, the gasket does not surrounded the internal inlet port between two plates. Now fluid enters through the port, flows between the plate and exit through the port at other end. So you may see that this is a thing and it may go out. On the same side of the plate, the other two sides are blocked by the gasket with a double seal, so that the other fluid cannot enter the plate on that side. Now there are two major type of gasketed and welded plate heat exchanger. One is the gasketed plate heat exchanger. This type is the fastest growing of the compact exchanger and most recognized. You can see this is the gasket. Now, a series of corrugated alloy material channel plates bounded by elastomeric gaskets are usually hung off and guided by the longitudinal carrying bars. These are the longitudinal carrying bars. Then compressed by large diameter tightening bolts. Here you see that these are the tightening bolts between the two pressure retaining flame plates. Here, if you visualize that these are the two retaining flame plate, or sometimes referred as cover plates. The frame and channel plates have potholes which allows the process fluids to enter alternating flow passage, that is the space between the two adjacent channel plates. Now, gasket around the periphery of a channel plate prevent any kind of a leakage to atmosphere, because ultimately it creates an economical loss. They also prevent the process fluid from coming in contact with the frame plates, so that the contamination can be prevented. No interfluid leakage is possible in the port area due to dual gasket seal. The frame plate, they are typically epoxy painted carbon steel material and can be designed per most pressure vessel code. So different type of codes are applicable, so through which it can be designed. The channel plates are always an alloy material with the SS304 as minimum. Now these channel plates are typically 0.4 to 0.8 millimeter in thickness and have corrugation depth of 2 to 10 millimeter. Special wide gap WGPHE plates or plate heat exchanger, they are available in limited size for slurry application with a depth of approximately 16 millimeter. Usually these channel plates are compressed to achieve metal to metal contact for pressure retaining integrity. Now these narrow gap and high number of contact point which change fluid flow direction combine to create a very high turbulence between the plates. So the inference of this that the high individual heat transfer coefficient, sometimes up to 14,200 watt per meter square degree Celsius, but also it creates a very high pressure drop per length as well. Now, in order to compensate the channel plate length are usually very short, mostly under 2 or few over 3 meters in length. So, in general, the same pressure drop as conventional exchanger, they are used without loss of the enhanced heat transfer. Expansion of initial unit is easily performed in the field without special consideration. The original frame length typically has an additional capacity of 20% or 15 to 20% to be more precise, more channel plate, that is surface area. In fact, if a known future capacity is known or available during the fabrication stage, because that is in designing stage, a longer carrying bar, it could be installed, and later increasing the surface area would be easily handled. Now this is a quite usual practice when one is scaling up or enhancing the capacity or increasing the capacity. So they need not to bother to have entire setup again. They may just increase the surface area by putting more and more plate and frame, and by this more and more compact. So at the start or at the initial fabrication stage, you can put a longer carrying bar. But if you are not certain, then if and at initially you are putting longer carrying bar, it may create a problem because sometimes the pressure as well as it will be an uneconomical affair. So when you are having the longer carrying bar, the expansion is needed. Simply untighten the carrying bolt, pull back the frame plates. You can put the additional channel plates and tighten the frame plate. So it is just like that. You are having the different plates. Initially you are having like this. You just open up, insert couple of plates, and then again tighten it. Let's discuss about the various applications. Now most plate type of heat exchanging applications, they are liquid-liquid service, but there are numerous steam heaters and evaporators used from their heritage in the food industry. Pasteurization of milk is one of the example. Industrial uses or users, they typically have Chevron style channel plates, while some food applications are washboard style. Now in this, the fine particle slurries in concentration up to say 70% by weight, they are possible with standard channel spacing. Wide gap units, they are used with larger particle size. Now typical particle size, it should not exceed 75% of the single plate. Now closed temperature approaches and the tight temperature control possible with the plate heat exchangers, and the ability to sanitize the entire heat transfer surface easily were a major benefit in the food industry. There are multiple services in a single frame, they are possible. Gasket selection is one of the most critical and limiting factor in plate heat exchanger uses. The higher the operating temperature and pressure, the shorter the anticipated gasket life, because the fluctuation and sometimes um, the plasticizers may go away, and the shelf life of gasket will be reduced drastically. So during the maintenance operation, one should have a closer look for this gasket life. Now the major applications, they are, but not limited to, they are the temperature cross applications for lean and rich solvent, close approaches applicable to fresh water to sea water to fresh water, and different type of viscous fluids. Now for this, there are certain sometimes you require the sterilized surface, polished surface sometimes required. Sometimes you may require the future expansion, so that the bars and other things you may look into the aspect. There may be certain type of limiting aspect with respect to the space restriction. You may have a barrier coolant system or services, some sort of the slurry application and the pharmaceutical emulsions. All these are some of the applications. Now let us talk about the corrugation. All plate heat exchangers look similar on the outside. The difference lies on the inside, in detail of the plate design and the sealing technology used. So it all depends that what kind of the sealing technology, what kind of the gasket, what kind of the other things you are using. Now an important aspect to take into account is that while evaluating a heat exchanger, they are in the forms of corrugation within the heat exchanger. Now there are two type of corrugation. One is the intermittent type of corrugation, and second is the Chevron corrugation. Now in general, the greater heat transfer enhancement is produced from Chevron for a given increase in the pressure drop, and are more commonly used than intermittent corrugation. Now the corrugated plate heat exchanger consists of a number of gasketed plates constrained between the upper carrying bar, if you recall the figure, and the lower guide bar. This is the lower guide bar and this is the upper carrying bar. So it depends on the number of gasketed plate constrained. Now the plates are compressed between the fixed frame, if you recall that these are the fixed frames. And the movable frame by using many tie bolts. So there are various tie bolts, if you recall in the figure. So these tie bolts are attached here, so you can tighten them and make more and more compact in nature. Now here you see that the structure of a typical gasketed plate heat exchanger with Chevron plates, you can see. Now here, this is the open plate pack. Now this is the fixed end cover, which is fixed, and here you can, this C is, this is the movable. So with the help of a bolt, you can tie it. Now this is the upper carrying bar over which all these plates are attached, and this is the lower carrying bar, and this is the support column. So if you are having the upper or a lower carrying bar with a bit larger in the length, then you can insert more and more plates. Now these are the tightening bolts, so you can introduce these tightening bolts, and here you see that this is the corrugated Chevron plate. Now here you see the corrugation over here, clearly visible, and these are the plate gaskets. So these are all these things, and here you see that the plate ports Now, it's the important geometrical parameter for plate heat exchangers. They are introduced and defined as per the previous figure. Now, usually while considering these aspects, the following parameters need to be considered as an essential parameter in plate heat exchanger simulation. One is the Chevron angle, that is phi, the corrugation depth referred as B, and the corrugation pitch. Now, here you see that different type of or you can visualize the different type of corrugation. Now, it is more and more visible, and here you see that this is the corrugation depth, and this is the Chevron angle you see here, and this is the corrugation pitch. Now, it has been convenient to define the different parameters like surface enlargement factor phi, and that calculated from this following relation, that is phi is equal to 1 upon lambda by 2 to the power integration from 0 to lambda by 2, the square root of 1 plus d upon d psi y psi the whole square d psi. Now, this y psi, this can be simulated by developing a design equation to optimize the heat exchange with respect to pressure drop. Now, for Chevron corrugation plate heat exchanger, the Chevron angle is the most influential geometric parameter. Now, here you see that we have represented three different combination. One is the high Chevron angle, that is high theta, you can see 120 degree. Here this is the low theta one, the Chevron angle, that is a 60. Now, here you see that it is a mixed Chevron angle, 120 and 60. Similarly, the single phase heat transfer, both the heat transfer and pressure drop increase with the increase of Chevron angle. Now, here you see the pitch and theta over here. So, this is the surface corrugation. Now, in addition, the aspect ratio of the Chevron corrugation has also played a very significant role on the heat transfer and pressure drop, because both of them increase with the increase of aspect ratio. Now, in the figure that the two-phase flow regime, the Chevron angle, this has a significant role or significant influence on the heat transfer region, usually characterized by the convection, such as convective boiling or shear controlled condensation. Now, here you see that the two-phase flow in the heat exchanger. In this particular chapter, we have discussed various anatomies of plate and frame heat exchanger. What are the importance of different type of angle, Chevron, especially Chevron angle. We have discussed about the broad spectrum of corrugated plate structure. Now, if you wish to have further reading, then we have enlisted various references for convenience. Thank you very much.